Whenever the limit of the function is not equal to the value of the function, we say the function is not continuous. Whenever x is equal to 0, f of x is defined as x only. So therefore, if f of x is x, then f of 0 is 0. Whenever a domain is defined for a particular function, it is clearly said to be continuous if it is defined at every point in the domain of f. If c is not equal to 0, the function is defined in the form of 1 by x. So if f of x is 1 by x, then f of c will be in the form of 1 by c. Hello everyone, a warm welcome to one and all. This is Yashruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So here in this session, we are going to start up with the very important chapter, that is continuity and differentiability. So in our previous sessions, we have learnt what is relations and what is function. So extending the concept, now we will be studying about what is the continuous function and how the function is said to be differentiable. In this session, we are going to study about the continuity of a function. So, let us take an example of a function f of x is equal to 1 for x not equal to 0 and f of x is equal to 2 for x is equal to 0. The graph of this function is defined as follows here. So, this is the graph of the function. What does the function says here? For any values x not equal to 0, the values is equal to 1. For example, for x is equal to 1, it is 1. X is equal to 2, it is 1. For minus 2, it is 1. For minus 3, it is 1. So, therefore, it goes. It's a straight line. But here, for x is equal to 0, the value is 2. So, therefore, for 0, the value is equal to 2. So, this is the point 0, 2. So, here we have a discontinuity at the point f of x is equal to 0. So, this is not a continuous function. In a simple way, if you can draw a graph without lifting your pen in a sheet, then it is called as continuous function. But here it is not possible. So when you draw a line like this, for this point you have to shift your pen or pencil to mark this point. So this cannot be a function. The other definition for the continuous function in the form of a limit is whenever the limit of a function at the point C, f of x is equal to the value of the function, then we say it is a continuous function. But here, left hand limit as well as the right hand limit, both x is equal to 0, that is behind 0 and after 0, the value of the function here is 1 and f of 0 is 2. So clearly, f of 0 is equal to 2, but here they are not equal. Whenever the limit of the function is not equal to the value of the function, we say the function is not continuous. So therefore, this is an example for a function which is not continuous. Thus, we have a definition for a continuous function, that is, a function is continuous at the point x is equal to c. So, this is the point x is equal to c whenever it is defined at the point as well as the limit of the function is equal to the value of the function. That is, the limit of the function at the point x tends nearer to c of f of x is equal to f of c, then only we say that it is a continuous function. Otherwise, we call it as a discontinuous function. Look here, check the continuity of the function f given by f of x is equal to 2x plus 3 at x is equal to 1. So here the limit of a function as x tends to 1, f of x is equal to limit as x tends to 1. What is f of x? 2x plus 3, which is 2 into 1 plus 3, which is equal to 5. This is the limit of the function. What is the functional value? What is the value of f of 1? f of 1 is 2 into 1 plus 3, which is again 5. So clearly what we can say, limit of a function as x tends to 1 is equal to the value of the function at f of 1. So therefore, since they are equal, we can clearly say that this is an example for a continuous function. Next, discuss the continuity of the function f given by f of x is equal to modulus x at x is equal to 0. What is the definition of the mod function? Whenever fx is equal to modulus x, then it is defined as x for all x greater than 0 or greater than or equal to 0 and minus x if x is less than 0. Whenever greater than lesser than is defined, you should take the limits in the form of left hand limit as well as the right hand limit. Now let us take the LHL. Since we have to check the continuity of a function at x is equal to 0, we take the left hand limit as x tends to 0 minus, here minus indicates the left hand limit. That is whenever x is less than 0. Whenever x is less than 0, we take f of x in the form of minus x. So if you put x tends to 0, it becomes 0. Since 0 do not have any sign, it is clearly 0. Let us take the right hand limit. So right hand limit, x tends to 0 plus here. So plus denotes the right hand limit. So whenever x is greater than 0, here the function is taken in the form of x. Now put x is equal to 0 here, so 0. The right hand limit and left hand limit are same, so therefore limit exists. Now let us check the value of the function at f of 0. Whenever x is equal to 0, f of x is defined as x only. So therefore, if f of x is x, then f of 0 is 0. So clearly what we can say here, the limit of the function as x tends to 0, f of x is equal to f of 0. So clearly the function is continuous. See here, the function must be defined at the point and the limit of the function at that point must be equal to the value of the function. Only then we say that the given function is continuous. One more definition we have for the definition of a continuous function, that is, a real function is said to be continuous if it is continuous at every point in the domain of f. We know that a function has its own domain and range. So whenever a domain is defined for a particular function, it is clearly said to be continuous if it is defined at every point in the domain of f. So we say a function is continuous at particular point, a function is continuous throughout the domain also. So previously we have discussed a continuity of a function at particular point. So here we are completely defining the continuity of a function towards the entire domain of a function. Only then we say that it is continuous function. Next question here. Discuss the continuity of the function f defined by f of x is equal to 1 by x where x is not equal to 0. Clearly they have given the function is not defined at the point x is not equal to 0. So when you apply or when you take any real number, so let's see belongs to any non-zero real number. So I'll take it as r minus 0 because we can't take x is equal to 0 here. So let c be any real number except 0. Then if you apply limit of a function f of x as x tends to c, since this function is defined as 1 by x, the value will be equal to 1 by c. Also, the functional value, that is, since c is not equal to 0, if c is not equal to 0, the function is defined in the form of 1 by x. So if f of x is 1 by x, then f of c will be in the form of 1 by c. Clearly, we can say the limit of the function as well as the value of the function is one and the same, and it is defined at every point except it is not equal to 0, that is except at 0. Hence, we say this function is continuous at the domain r minus 0. Next question. Discuss the continuity of a function f defined by f of x is equal to x plus 2 if x is less than or equal to 1, x minus 2 if x is greater than 1. So we are discussing the continuity of a function at the point x is equal to 1 here. So at the point x is equal to 1, the functional value will be equal to 1, 3. And here clearly you can see by the graph, this is an example for discontinuous function. Why? I have already told you, whenever the continuous function is defined, the graph can be written without lifting a pen. But here we have to draw separate two straight lines to define a function. So this is not an example for a continuous function, or we can say this is a discontinuous function. Now let us prove it theoretically. So let us take, since I already told you whenever less than and greater than is defined as inside the function, take the left hand limit as well as the right hand limit. So let us take the left hand limit. So left hand limit is limit of a function as x tends to 1 minus, that is x less than 1 denotes the left hand limit, behind 1 which is left hand side. So left hand limit is whenever x is less than 1, the function is defined in the form of x plus 2. So when you put x is equal to 1, so minus indicates only the left hand limit. Do not take the value as minus 1 here. The value must be taken as 1 only. So it is 1 plus 2, it is equal to 3. Now let us take the right hand limit. Right hand limit, that is limit as a function as x tends to 1 after 1, that is 1 plus, so greater than 1, it is defined in the form of x minus 2. So it becomes 1 minus 2 is equal to, here it is minus 1. So clearly the left hand limit is not equal to right hand limit. Also f of 1, that is whenever x is equal to 1, which is nothing but f of 1 is nothing but 1 plus 2, which is equal to 3. So left hand limit is not equal to right hand limit, means limit does not exist, and the functional value is also not equal to the limit value. So clearly from these observations we can clearly say f is not continuous function at x is equal to 1. And one more observation we can see here, except point 1, except the point near 1, the function is continuous. Hence we say the only point of discontinuity for this function is x is equal to 1, because only at the point x is equal to 1 the graph breaks. So here it is exactly continuous and here it is exactly continuous, but at this point it is not continuous. Hence we say 1 is the point of discontinuity of a given function. So other than this, we come across many types of function. We can also verify or prove how the function is continuous. So here are some examples here. Every polynomial function is continuous. So all the polynomial functions, it may be a linear, quadratic or cubic or biquadratic, any type of polynomial function is always a continuous function. Next is the greatest integer function is discontinuous at every integral point. We know that the graph of the greatest integer function will be like this. So here also like this. So clearly from the graph you can see at every integral point it is discontinuous, and till certain interval it is continuous, but when it comes to particular integer it breaks. The point is shifted to another point. So we can't write the graph without lifting the pen, and clearly we can say, since we have many breaks here in the graph, clearly we can say it has a discontinuity at all the integral points. The next is algebra of continuous function. What is this algebra of continuous function say? Suppose we have two functions f and g, both are continuous. Then what will be the sum, difference, product and quotient of these functions? So whenever two functions are continuous at the given point or at the given domain, then we say f plus g is also continuous at x is equal to c. For example, if we have x is continuous as well as x square is continuous, then x plus x square is also continuous function. Similarly, x minus x square is also continuous function. That is, f minus g is also continuous at the given point. And the product f dot g is also continuous at x is equal to c. And we have f over g provided g of c, that is a function at this point should not be equal to 0. So only when this is continuous at x is equal to c. So this is only an extra condition, that is the g of x should not be equal to 0 at the point c. Then only we can define f by g as a continuous function at the given point. So we can take few examples. Every rational function is continuous. So f of x by g of x. So all functions in the form of f of x over g of x, where g of x is not equal to 0, and these two are all polynomial functions. So this is what rational function, right? So a function in the form of f of x by g of x, where both f of x and g of x are polynomial functions and g of x is not equal to 0. We have already learned every polynomial function is continuous, and here it is defined the denominator is not equal to 0. So with the help of algebra of continuous function, whenever the denominator function is not equal to 0 and both are continuous, clearly we can say a rational function is continuous. And one more, sin x, cos x and tan x are continuous function. So whenever the trigonometric function sin x, tan x, cos x are continuous, you can look at the graph of sin x, it will be like this. So these are all example for continuous function. So that's why the sin x plus cos x will also be continuous. Sin x minus cos x will also be continuous at given point and domain. So next we have a theorem on composition of function. We have already learned what is composition of function. A function of a function is nothing but composition of a function. What does this theorem says? Whenever we have two functions f and g, are real valued function such that f naught g is defined at c. This is defined. That is, a composition of function is also defined at the particular point, and if g is continuous at c and if f is continuous at g of c, then f naught g is continuous at c. So example, here I have taken sine of x square. We know that x square is a polynomial function and it is continuous. Sin x is also a continuous function. Therefore, the composition of sine of x square will be continuous at the given point. So, this is how the composition of a function is defined. So, when g is defined at c and when f is defined at g of c, then f naught g is defined at c, which will be a continuous function. So, next question we have, find all points of discontinuity of f, where f is defined by f of x is equal to 2x plus 3 if x is less than or equal to 2, 2x minus 3 if x is greater than 2. So let me take a real number as a domain of this function. Let me take any c belongs to R here. So we have three cases according to this. The very first case, if c is less than 2, then f of c will be equal to 2c plus 3. Now let me define limit as x tends to c of f of x. So here we have limit as x tends to c 2x plus 3, which can be taken as 2c plus 3. So clearly these two are equal. So whenever these two are equal, this implies f is continuous at all points where x is less than 2. So if it is continuous at point c is less than 2, since c is a point which is less than 2, we can take x is less than 2. So next we take a function, here c greater than 2 here. So whenever the c is greater than 2, the function is defined in the form of 2c minus 3. Similarly, when you apply the limit as x tends to c f of x, this will be again equal to 2c minus 3. Hence, we can also write f is continuous at all points x greater than 2. So, the next case here is whenever c is equal to 2. So, this is the third case. So, whenever the c is equal to 2 here, f of c is actually 2x plus 3. So, therefore, it is equal to 2c plus 3. But what happens to the left hand limit as well as right hand limit? So here LHL is not equal to RHL. You can see from cases here. So because the left hand limit is equal to 2c plus 3 and right hand limit is equal to 2c minus 3. They are not equal. If they are not equal, limit does not exist. If limit does not exist, what we can conclude? The limit of a function at x tends to c is not equal to f of c here. That is, when you apply the limit as x tends to 2 for f of x, it is not equal to f of 2. So therefore, the function f is not continuous at the point x is equal to 2. In all the other cases, it is continuous. Therefore, the only point of discontinuity for the given function is x is equal to 2. Next, f of x is equal to modulus x by x if x is not equal to 0 and 0 if x is equal to 0. X is not equal to 0, we have two cases, that is when x is less than 0 and when x is greater than 0. This function can also be rewritten in the form of, we know that mod x can take two values, one is x and one is minus x. What happens if x is less than 0? If x is less than 0, modulus x is defined as minus x. So here this will be equal to minus 1 and it is 0 if x is equal to 0. What happens if the function is greater than 0? Whenever the value is greater than 0, modulus x is positive only. That is, mod x by x is nothing but x by x. So therefore the value is equal to 1. So clearly, as you defined here itself, f of 0 is 0. Look at the left hand limit. Left hand limit is equal to minus 1. That is, when x is less than 1, it is minus 1. And what about the right hand limit here? So right hand limit is equal to plus 1. Clearly you can see the function is not continuous because the left hand limit as well as the right hand limit is not one and the same, and it is not equal to the value of the function also. So if you draw the graph for this function, you can see, so if this is 0, so for x less than 0, the value will be equal to minus 1. It will go on like this. So this is minus 1. And for x is greater than 0, the value will be equal to plus 1. So this goes on like this. And for x is equal to 0, this is 0. So from the graph, you can clearly see at 0, it is continuous. And at greater than 0, it is continuous. And at less than 0, it is continuous. That is, for all the points, x greater than 0 as well as x less than 0, it is a continuous function. But at the point x is equal to 0, it is discontinuous. Therefore, the only point of discontinuity for this given function is x is equal to 0. Because you can clearly say you have to lift your pen and write these two lines here. So therefore, here we have to write an open circle, because it is not defined at that particular point, because f of 0 is 0 and f of x is 1 for x greater than 0 minus 1 for x less than 0. So clearly from this definition and graph, you can clearly say x is equal to 0 is the only point of discontinuity for the given function. Next question we have here. Find the relationship between a and b so that the function f is defined by f of x is equal to ax plus 1 if x less than or equal to 3, bx plus 3 if x greater than 3 is continuous at x is equal to 3. Clearly, they have given the function is continuous. Whenever the function is continuous, the left hand limit will be equal to the right hand limit and it will be equal to the value of the function. So therefore, from these definition, so let's take the left hand limit. What is our left hand limit? The function whenever x is less than 3, that is limit of a function as x tends to 3 minus here f of x is defined as ax plus 1, which can be written in the form of, so here x must be given the value of 3. So therefore it will be equal to 3a plus 1. And what is right hand limit? Right hand limit as a function as x tends to 3 plus here. So whenever x is greater than 3, the function is defined as bx plus 3. So therefore this is 3b plus 3. And what is the value of the function? That is f of 3. C means at x is equal to 3. Whenever x is equal to 3, the function is in the form of ax plus 1. So which can be written as 3a plus 1. Now by using this definition, we can clearly write 3a plus 1, 3b plus 3 is equal to 3a plus 1. Since these two are equal, we can write 3a plus 1 is equal to 3b plus 3, or we can write 3a is equal to 3b plus 2, or a is equal to b plus 2 by 3. So this is the relation between a and b. Next, find the value of k such that the function is continuous at the indicated point. So f of x is equal to k cos x divided by pi minus 2 into x if x is not equal to pi by 2, and 3 if x is equal to pi by 2. So here it is continuous at the indicated point, means here we have to take the function is continuous at pi by 2. Since f is continuous at x is equal to pi by 2 here. So f of pi by 2 will be equal to 3 because at x is equal to pi by 2 the value is 3. So now let us find out the limit of the function. So whenever the function is given in this form not equal to, both LHL and RHL have the same value of the function here. So therefore just find out the limit of a function. So therefore limit of a function at the point x tends to pi by 2, f of x can be taken as limit as x tends to pi by 2, k cos x divided by pi minus 2x. So here let me take x is equal to pi by 2 plus h. So therefore limit changes. As x tends to pi by 2 here, h tends to 0. So let me interchange the variable with respect to h now here. So what happens to this function here? Then this becomes limit as h tends to 0, k into cos of, so what I have taken the value of x as pi by 2 plus h. So this becomes pi by 2 plus h whole divided by, and here pi minus 2 into pi by 2 plus h. So now here we have got k into cos pi by 2 plus h. We know that, so this is 0, pi by 2, pi, and here it is 3 pi by 2. So what is pi by 2 plus theta means? It lies in the second quadrant. So in the second quadrant, whenever you have 90 plus theta, the function changes to co-function. We have learned with the help of allied angles in trigonometry. So therefore, cos 90 plus h can be written as sin h. But what is the value of cos in the second quadrant? It is negative. So therefore, this can be written as limit h tends to 0 minus sin h. And we have k outside here. And here when you solve this, you will get pi minus 2h. So pi get cancels. We can take k and 2 outside. So again here minus also get cancelled. So we are left with limit as h tends to 0, sin h by h. So this is the standard theorem which we have learnt in the chapter limits and derivatives in your first PUC, which states the theorem, that is limit of sin theta by theta whenever theta tends to 0 is equal to 1. So therefore the value will be equal to k by 2. So we know that the function is continuous at x is equal to pi by 2. So therefore what we can say here, limit of the function as x tends to pi by 2, f of x is equal to f of pi by 2. So that is, we have got here k by 2 is equal to 3. So therefore the value of k is equal to 6 here. Next question. F of x is equal to kx square if x is less than or equal to 2, 3 if x is greater than 2. The same thing, we have to find the value of the k at the point 2 whenever the function is continuous. Now let's see, since this is a continuous function, we have less than and greater than, so we have to calculate both left hand limit as well as right hand limit separately. Let's see what is f of 2, because the point is defined at x is equal to 2. So f of 2 is k into 2 square, which is equal to 4k. What is left hand limit? Left hand limit, that is limit as x tends to 2 minus. F of x is defined as here kx square only, which is nothing but same k into 2 square, which is equal to 4k. Now let me take the right hand limit, that is whenever the function x is greater than 2. Whenever it is greater than 2, the function is 3. So the value is equal to 3. So since the function is defined at the point x is equal to 2, and since it is also continuous, we can write LHL is equal to RHL, and it is equal to the value of the function at f of 2. So what is LHL? It is 4k. What is RHL? That is right hand limit. This is 3 and this is same. So this implies 4k is equal to 3, or we get k is equal to 3 by 4. So this is the value of k. The next question, f of x is equal to kx plus 1 if it is x less than or equal to pi, cos x if x is greater than pi. Now let's take f of pi. What is f of pi? Whenever x is equal to pi, f of pi is k into x plus 1, which becomes k pi plus 1, or we can write pi k plus 1. So next we can take the left hand limit here. So left hand limit is limit of a function as x tends to pi minus. Whenever x is less than pi, the function is defined as kx plus 1. So here kx plus 1, which becomes pi k plus 1. Next we have right hand limit, that is limit of a function as x tends to pi plus. So whenever x is greater than pi, it is cos x, which is cos pi. So cos pi value is minus 1. Now since the given function is continuous at x is equal to pi, what we can write, LHL is equal to RHL and it is equal to f of pi. So what is the left hand limit? Left hand limit is pi k plus 1 and right hand limit is minus 1 and f of pi is pi k plus 1. So from this we can clearly write pi k plus 1 is equal to minus 1 or pi k is equal to minus 2 or k is equal to minus 2 divided by pi. So this is the value of k. So this is all about the continuity of a function. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.